Welcome back to Topic 1 for Algebra 2, Solve Complex Linear Equations. In this video, we're going to review the distributive property and then solve 3 practice problems. Let's begin. So, as a reminder, the distributive property is A times B plus C equals A times B plus A times C. And we're just treating A, B, and C as just generic numbers here. If we want to use actual numbers, this is the same thing as, for example, 5 times 4 plus 6 equals 5 times 4 plus 5 times 6. And remember, when simplifying that, we want to think about PEMDAS, so solve with our multiplication first and then go to adding. Our goal with solving linear equations is to isolate and solve for the variable. So basically, we want to get the variable alone, so it's just the variable equals and then our value. Our first example here, we start with a fraction. We have 3/2 times 3y plus 5 equals negative 24. So we want to solve for this unknown variable here, this y. First, what I'm going to do is apply the distributive property since I see this 3/2 chilling on the outside. So we're going to apply to every single thing that we see inside that quantity. Now this is really 3y over 1 and 5y, just 5 over 1. Once we apply that, we get 3/2 times 3 over 1y, which is the same thing as 9/2 y. And this y would be in the numerator, or you can put it to the side, because remember, there is an actual multiplication dot right there. It's just sometimes we don't always write it. And then 3/2 times 5 over 1 is the same thing as 15/2. And this is all equal to negative 24. Now right here, what we have is a 2-step equation. It just looks a little more complicated because we're dealing with fractions. So we still want to isolate that y, so we're going to subtract 15/2 from both sides. Because remember, what we do to one side, we have to do the other. You can also feel free to draw a vertical line through right underneath the equal sign if that's helpful for you to kind of differentiate between either side. On the left-hand side, we have inverses, a positive and negative of the same amount, so they cancel, they add to 0. So we're just left with 9/2 y. And on the right-hand side, we have negative 24 minus 15/2. Now, they do not have a common denominator, so we cannot just do negative 24 minus 15. Instead, we need to convert this. Negative 24 is the same thing as negative 48/2. And then we're going to take away 15/2. Now that they have the same denominator, we can subtract our numerators. So we'll get 9/2 y equals negative 48 minus 15. That's the same thing because they have the same signs, negative 48 and negative 15. So we're going to add those two numbers and carry the sign down. So negative 48 minus 15 is negative 63. And then that same denominator of 2 there. So right here we have 9/2 y equals negative 63/2. So we can do a couple of things. We can cross multiply if we remember that our y is in the numerator with that 9 on the left-hand side. Or because ideally we want to get this y alone, this y and the 9/2 are tied together with multiplication. So the opposite of multiplication is division. So we would divide both sides by 9/2. However, dividing by a fraction can get a little funky. So if we divide by a fraction, that is the exact same thing as multiplying by its reciprocal. So the reciprocal of 9/2 is 2/9, and what we do to one side, we have to do to the other side. Now if we go through and simplify, we'll have 2 times 9, which is 18, over 9 times 2, which is also 18. So that will simplify to just 1y. Or we see a 2 in the numerator, 2 in denominator, that simplifies to 1. 9 in the numerator, 9 in the denominator also simplifies to 1. So we are left with y on the left-hand side. On the right-hand side, we have negative 63 halves times 2 ninths. Again, we see a 2 in the numerator and a 2 in the denominator, so that simplifies. And we have negative 63 divided by 9, or negative 63 ninths. This is the same thing if we simplify, that y is negative 7. And there we go. Moving on to our next example here, we have x minus 2 divided by 5 minus x minus 4 divided by 2 equals 2. So we want to isolate this x, but we don't just have one variable here, we actually have two. So we have to figure out some way to combine them. However, because they have different denominators, we can't simply subtract them. We have to get the least common denominator. The least common denominator is the same thing as the smallest multiple of both of these denominators. So oftentimes what you can do is you can multiply the two numbers together. However, that is not always going to give you the smallest multiple. You would just need to reduce in the future. It will still work, but you would need to reduce later on. So in this case, what is the smallest multiple of both 5 and 2? In this case, it is 5 times 2, or 10. So what we're going to do is what we do to one side, we have to do to every single side. So I'm going to rewrite this problem just a little bit bigger right below. So we're going to multiply this quantity by 10, and this is 10 over 1, by the way. We're going to multiply this quantity by 10, as well as on the right-hand side. Now, if we just look at our new numerators and denominators, we could distribute if we wanted, but we want to get x alone. We don't want to make it more complicated. So we have this 10 divided by 5. 5 goes into 10 2 times. And with our second part, 2 goes into 10 5 times. So we can simplify that way. Now we don't have any fractions, we don't have any denominators that we're dealing with. So we simply have 2 times x minus 2 minus 5 times x minus 4 equals 10 times 2, or 20. Now we can apply the distributive property. So 2 times x is 2x minus 2 times negative 2 is 4. Then we have negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20 equals 20. Now we can just combine our like terms, get our variable on one side and our constant on the other. So our like terms here, we have 2x and negative 5x. That adds to get negative 3x. And then we also have negative 4 and positive 20. That adds to get positive 16, and that's set equal to 20. So right now we have a two-step equation. Since we want to get our x alone, we're going to deal with this plus 16 first, our kind of third wheel. So the inverse of adding 16 is subtracting 16. What we do to one side, we have to do the other. Oops. So we have negative 3x equals positive 4. Now, since this is negative 3 times x, we're going to divide both sides by negative 3. And we will end up with x equals negative 4 thirds. Moving on to our final example here. Here, we do not actually have any other numbers besides 2. So we have a equals b1 plus b2, that stands for base 1, base 2, divided by 2 times h. Now, this is actually the formula for the area, that's what the A symbolizes, of a trapezoid, because it has two different bases, the top and the bottom. So in order to figure out or to simplify this problem, all it's asking for is for us to solve for h. So in other words, isolate h. If we look at this problem, we have b1 plus b2 divided by 2 times h. So this entire quantity is times h. So we can solve this problem a few different ways. We can do a few steps. So we can rewrite this to be a equals b1 plus b2 over 2 times h over 1. And this would actually simplify to a equals b1 plus b2 times h all over 2. So if we want to do this, we can, since we see division here, we can multiply both sides by 2. I'm going to rewrite it here. So we're going to multiply the right-hand side by 2 and the left-hand side by 2. On the right-hand side, 2 divided by 2 reduces to just 1. So we're left with 2a equals b1 plus b2 times h. Now we could distribute, but again, that would make our problem more difficult. We want to get h alone, get it isolated. It needs to quarantine. So since this is b1 plus b2 times h, the inverse of multiplication is division. So what we do to one side, we're going to do to the other. So we're going to divide by the sum of b1 and b2. On the right-hand side, that's going to cancel, and we're just left with h. And on the left-hand side, we have 2a divided by b1 plus b2. So that was one way to get our final answer. There is many other ways. One other way that I wanted to show you all is if we have a equals b1 plus b2 divided by 2, and then this is all times h. So because they are multiplied together, the inverse of multiplication is division. So we can actually divide both sides of our equation by b1 plus b2 divided by 2 and b1 plus b2 divided by 2. On the right-hand side, it will cancel. But this actually looks a little bit wonky. Remember, dividing fractions is the same thing as multiplying by the reciprocal. Don't ask why, just flip and multiply. So this is the same thing as a. Instead of divided, we're going to multiply by 2 over b1 plus b2, and that's going to equal h. So this is really a over 1, so if we simplify it, now traditionally in standard form, we're going to write our number first. 2a divided by b1 plus b2 equals h. And that's the exact same answer that we have on the other side. Now, a quick thing that I do want to point out is there is something that we do have to mention. Because we are dealing with a fraction, we can never divide by a specific number. We can never divide by 0. So we have to make sure, write a little note to ourselves. There's an exception. The sum of b1 plus b2 cannot equal 0. Or in other words, b1 cannot equal the negative of b2. Now, oftentimes, if we're dealing with a real-world situation, bases would not have negative values, but we just have to put that little note in just for our answer to make sure that we are not dividing by 0 because b1 and b2 are not already predefined. And that was topic 1 for Algebra 2, solving complex linear equations. Thanks for watching.